Welcome to the second video on constant velocity challenge questions. We're going to be doing number 2 now. It says the 800-meter race usually consists of two 400-meter laps. If a runner runs the first lap at an average speed of 6 meters per second and the second lap at an average speed of 4 meters per second, what is her overall speed? And it suggests drawing a quantitative, which means that we're going to include the numbers, position time graph, and that may help. Alright, so here's a quick little position time graph. Now, the maximum position that they're going to be doing is 800 meters. So I'll put a little 800 there, and maybe halfway down I'll put a 400. And here's my origin. So the first lap is going to be an average speed of 6 meters per second. So on a position time graph here, then the slope of this line will be 6 meters per second. So maybe I'll just write 6 meters per second there. And then for the second, 4 meters per second. So I'm going to exaggerate maybe a little bit here. So it's going to go at a not as steep, less steep. And I didn't even make it to 800 yet, did I? So I'm going to actually have to draw it farther. Well, this is something that's interesting, and we see right away now, is that it's going to go the same distance, it's going to require more time here. So that the second lap actually takes longer than the first lap because they're not going as fast. They're only going 4 meters per second. So I'm just going to resist the urge to say, hey, the answer is 5, because this is a challenge question. It can't be that easy. So I'm going to call this first segment A, here A, and this one B. So over here, let's keep track of this. And then I'll do another one for total. So my total would be the line joining the beginning and the end. I'll try to make that at the same spot. So the last one would be total. Okay, so let's see. Well, what do we know? For the first section, we know that the velocity is 6 meters per second. And we know that the change in position is 400 meters. So again, using our definition of velocity and solving for time, if we solve for time, delta t is going to be equal to delta x divided by v. So this would be 400 meters divided by 6 meters per second. And so I end up getting, when I type into my calculator, I get 6.6 repeating meters per second. In other words, a good time here to use our memory in our calculator if we have it. So for B, I'll see if I can just separate this a little bit here. So for B, I don't have a lot of space here. I'll go like that. I'll even switch. No, okay. The velocity for B is 4 meters per second. Now, what is the displacement? What's the change in position? It's not 800 because the change in position would be like from 400 to 800, so only 400 meters again. So now the time to do this one is going to be equal to delta x divided by v, which is going to be 400 meters divided by 4 meters per second. I think we can do that one in our head. That would be, 100 seconds. I said oops because this is seconds. Okay, so the first lap takes 66.6 seconds. So I can put that over here, 66.6 repeating seconds. And then so this one would be the two added together. It would be 166.6 repeating seconds. Try to draw that a little nicer. Okay, so now we're talking total. So for total, V is equal to the total displacement divided by the total time. So the total displacement is 400 plus 400, which is 800 meters. The total time will be 166.6 repeating seconds. So when I do 800 divided by 166.6 repeating, I get 4.8 meters per second. So this, you might wonder, how come I can't just average 4 and 6 together? Well, the reason is although they went 6 meters per second for the same position, for the same displacement for that 400 meters, and then B also for 400 meters, they spent more time at going the slower speed at 4 meters per second. So that had a greater influence overall. If you went 6 meters per second for an hour, and then 4 meters per second for an hour, then you can just average 6 and 4 and get 5. But in this case, if you're separating it by equal distances, not by equal time, it doesn't work out that way. So that is the answer. All right, I hope that helped. Thanks.